Hello, statistics student. This video is for chapter 12.2 and 12.4. We're looking at scatter plot and correlation. So we say in the last video that scatter plot is useful for looking at the general patterns of the line of the points, if they are upward trend, downward trend, and if there's any nonlinear correlations. So, and then we say there is another number that we can calculate that can also give us some infos about how strong the correlation is, and also if it's positive or negative, and that is correlation coefficient R. So correlation coefficient is really long, so sometimes we just say R. So what are some of the properties of this number R? We said that it is, no matter how you calculate it, it has to be between -1 and 1. So so it could be 0, it could be 1, it could be -1, or it could be any number in between. So in the extreme case, if it is 0, that means there's no correlation. You will see the dots all over the place. And if R equal to 1, that means it's perfect positive correlation. If R is equal to -1, perfect negative correlation. When it is close to 1 or 0, that is strong. So in this neighborhood, if R is like 0.8, 0.9, that is strong correlation. So you see that points lines up. So but when they're close to 0, like 0.1, 0.2, or -0.1, so these are when you have weak, right? Weak positive, weak negative. So if R is positive, then you have a positive slope. In general, you will see the points goes up, and if R is negative, you see a negative slope. Okay, so R and the scatter plot are strongly related. So the second thing we want to just to emphasize, or to for us to better understanding the value of R in relation to correlation, is look at what R value our graph has. So we talked about this before. When R is 0, you see dots all over the place, and if you try to draw a pattern, it would just be a horizontal pattern. And when the lines up really good positive, R is 1. When it lines up really good downward, then R is -1. When it is close to the line, then it's 0.8 or -0.8 for negative. When it is spread out, then it is 0.3 and -0.3. So this one is negative. It's not very clear, but this is positive. So you can kind of get the idea. But you would say, well, what about 0.5? Do we say it is strong or not? And so we'll talk about those later too, because there is a critical number. There's a critical threshold that we can say after this number, then there is linear correlation, and before that there is no. So before we go into doing this, I want to introduce our games that we will play in class. In case you don't come to class or miss class, you should play this yourself, because it would help you to understand the relationship between R as well as the scatter plot. So you would go to this site. What you can do is you can just say correlation game, and it will shows up like this. Get new plots. So they will give you 4 scatter plot and 4 R, and you have to match them. Okay, so these are all 4 R. That's the same. So you can just go by elimination. So so in our case, we have this is down, this is negative, this is negative, right? There's only one positive, so I would say this is 193, and it's quite strong, right? Which one is the strongest negative? The strongest negative is close to -1, right? So I should choose -0.99. The next strong negative is -0.94. And the very weak one, really close to 0, is -0.19, right? So check answer. So play this a few times, you would have a better understanding of R and the scatter plot. So the worksheet also require you to have a understanding of how to differentiate between the appropriate appropriate R if you're given a scatter plot. I think the main thing you need to get in your head is when R is 0, there's no correlation. Okay, when R is 1 or -1, that's very strong. The next step is to determine if the match pair has linear correlation. In general, we say, well, if it's 1 or -1, that is very strong correlation. But where is the threshold? If I have 0.79, I have 0.8, is it strong? Right? So it turns out that it depends on the sample size also. The higher the sample size, the threshold will be lower. If you have very small number of data, your threshold is quite high. But in general, these are the steps. First, you have to check your scatter plot to see if there's any nonlinear pattern. If you have nonlinear pattern, there's no need to check the other things because they are not linear. No matter how good your R is, they're not going to be linear. Step 2 is use a hypothesis method because whenever we have to check threshold, hypothesis method is very good. So the hypothesis test that we do is called the linear regression hypothesis. Basically, what it does would be you assume that there is a population parameter called rho. So this is a Greek letter, right? Almost like P, but it's actually rho. And this is the correlation coefficient if you have all the population data. The hypothesis test is rho equal to 0. And when it is equal to 0, that is the same as R equal to 0, no linear correlation. The alternative is not equal to 0, so either positive or negative. And where do we find the p-value? I find the p-value using the same method that I find R. So if you do analysis, correlation and coefficient, correlation and regression, you select your match pair data. You will have under the correlation result because we're studying correlation, right? So these are the few numbers: correlation coefficient R, critical R, and p-value. Okay, the three numbers that you should write down. The p-value are two-tailed. Why? When we do our hypothesis test, you can see that it was not equal to, right? So when you do this hypothesis test, you don't have to write any claim or whatever. This is always X0 and HA. Okay, so all you need to do is to find the p-value and you don't have to set anything. So only the p-value and you compare with alpha. If it is less than alpha, that means you reject the null hypothesis. Null hypothesis say no correlation, you reject it. It means you conclude linear correlation. Okay, low p-value means linear correlation. Okay, so this is a repeat. If p-value is greater than alpha, then you say fail to reject the null hypothesis, conclude no linear correlation. So because it agreed with X0, X0 say no correlation, so there's no correlation. So that's one method, use p-value. It's the quickest method. But you have to remember which one is which. Okay. The second method is use the two number that we talked about, R and the critical R. Okay. Critical R is what you read off from the analysis correlation coefficient. And what happened is we talked about this before. When is R good for signifying linear correlation? It is when it's close to 1, right? But we don't know where is the threshold. So the threshold are the critical R. The critical R usually is plus and minus a critical value. So we call it CV. So this is a negative CV and this is the positive CV. If they are in here and close to 1, right? Over the threshold close to 1, that is linear correlation. So you do not want it to be close to 0. Close to 0 for R is no correlation. So this is negative linear correlation. So you want it to be at the 2n. So we don't say that has to be big. Well, because when it is close to -1, it's small also. So it's the two side for linear correlation. When it is in the middle, there's no linear correlation. It might have other correlation, but no linear correlation. Correlation, right? So I think a picture is good. So whenever you have to check So if you don't like to do p-value, you can use this method. But in both cases, you have to make sure that you check scatter plot to make sure there's no nonlinear pattern. So let's do some practice. I have someone give a pair of x, y data, and they run statistic give r equal to negative 0.823. Critical is plus and minus 0.754. Are there linear correlation? So I'm going to draw a picture. Negative 1, 1. Negative 0.75, right? Positive 0.75, 0.75. My number is negative 0.823. Does it go through does it pass the threshold? Yes, it does, right? Our number is here, negative 0.823, so it is linear correlation. Some books also use absolute value, so that's also okay, but I think this is also easy to do. You just do the threshold. The second pair is you use p-value and alpha. So 0.012 is less than 0.05, right? So reject like 0. Oh, I have written it in the notes. So when you reject 0, you conclude there is linear correlation because x0 is rho equal to 0, no linear correlation. So if you reject it, that means there is linear correlation. No linear correlation. Um, so another example would be actually use the adult heights and shoe size things. We already did that, and I have I have yeah, we already did that. 0.8485, critical 0.878, p-value 0.06915. That's the height and shoe size. The scalar plot actually shows up here. But they have the line that you cannot get out. So if you want to, you can use this scatter plot, but when you are to copy down a scatter plot, please do not copy this line. A better way is to use the real scatter plot, so you do not have to. You can have an option of take away the regression line. So that is better. That is no regression line. Let's go back to correlation coefficient. The three number that we have. Height and shoe size. We put 0.05 here because this would dictate the critical R. Okay. If you change this, okay, so maybe I'll change it to 1. You see that the critical R change. See, the critical R become 0.9, right? So if I use 0.05, which is what we have in the example, our critical R is 0.878. Okay, so let's go back to what we're doing. Um, that's the classwork. Okay, so I write down this is the second one. I write down the scatter plot. So when you write down a scatter plot, I didn't do a good job. I did not label anything. So make sure you label the number and you tell that, oh, this is what this is height, right? Because it's X, and this is shoe size. And you should also right? Like this is 8 and this is 12. At least it has some marking, okay? Some scale, some label. And then you describe it a little bit. You say that the graph does not show linear pattern. There seems to be an upward pattern. So you can see seems to be an upward pattern, right? Upward positive correlation pattern. Is it strong? It's not very strong. So and then we have to check if there's linear correlation. So I do both of them. P-value method, 0.0691 is just greater than 0.05. So conclude no linear correlation. Method 2, look at 0.8485 with the critical method, right? Critical R. So critical R is 0.87. Because you only have 5 data, they have to be, the threshold is really, really hard to go through. Positive 0.878, negative 0.878, but you only have x4, which is actually closer to 0, right? Because you did not go through the threshold. The threshold is the one that you have to pass in it for 1. So also conclude no correlation. So that's how you do the correlation evaluation. We have another example. We'll do it in the next video.